Good afternoon students. Welcome back to online maths class. So in today's class we are going to discuss about the maximum and minimum values of a function in a closed interval. So here I have drawn the graph of a continuous function in the closed interval a comma d. So here observe the points a, b, c, d. So at the point b you are going to have the local minima. At the point B is going to be the point of local minima, whereas C is going to be the point of local maxima. So compare these 2 points. So here this is also maxima and this is also the maxima, whereas this is also the minima and this is also the minima. So here we are going to discuss about absolute maximum and absolute minimum. So now in the earlier classes I had given an example. If we take the toppers section wise, suppose if we have 4 sections here A, B, C, D and E. Overall in any college if we have 5 sections, so from each section there will be a topper from every section. So from this section there will be a topper and from this section again there will be a topper. So from every section you will have a topper, but overall if we consider the entire college, so there will be ultimately one topper. So ultimately one topper. So that means you can have the maximas, but if we consider the entire function, there is only one the greatest value or the global maximum value. So here this will be the absolute maximum or the global maximum, whereas this will be the absolute minimum or the global minimum. This is the least value, whereas this is the greatest value. These two are the local minimas and local maximas. Locally you are comparing, that is why this is the local minima and this is the local maxima. That we have to write now. So here at this point you will get the absolute maximum value, absolute maximum value at this point. That means here you will get what is that? It is f of a. F of a will be the absolute maximum value, f of a, and then what is this now? At this point you will get f of d. So from here if you draw a line, at this point you will have f of d. F of d is the absolute minimum value, the least value out of all these. So this will be the absolute minimum value. So now what about at the point B and at the point C? At this point you will have the local maximum value. So this is f of c. So here you get f of c. F of c will be the local maximum value, and then at this point B you will get, if you draw a straight line here, at this point you get f of b. What is f of b? It is local minimum value. So here this f of b will be local minimum value. So now what are the points A now? Points A, B, C, D. So A will be the point of absolute maxima and D is the point of absolute minima, whereas B is the point of local minima and C is the point of local maxima. This is regarding the maximum and minimum values of a function in a closed interval. Closed interval means you have to take the end points as well as the in between value. So with the help of this knowledge we are going to give the working rule for finding the absolute maximum and absolute minimum values of a function. For example, if a function is given f of x equal to some function, how do you find the absolute maxima and absolute minima? That working rule we are going to discuss now. So note down this, then we'll give the working rule for finding the absolute maxima and absolute minima. So the next heading is working rule. Working rule for finding. Working rule for finding absolute maxima or maximum, absolute maximum or absolute minimum, or absolute minimum, or absolute minimum. So suppose a function is given, you have to go for the derivative of the function and equate that f dash of x with the 0 to get the critical point. So the first step in this working rule is going to be find all the critical points in the interval. So step 1 will be find all the critical points. Find all the critical points in the interval. Find all the critical points in the interval. Find all critical points in the interval. So once you get the critical point, you have to evaluate the given function at the critical points as well as at the end points of the given interval. That is going to be our second step. So here second step will be evaluate the function f. Evaluate the function f at the critical points. Evaluate the functions at the critical points and at the end points of the given interval. And at the end points of the interval, endpoints of the given interval. So this is the second step, and then the last step is going to be identify the maximum and the minimum value. So this maximum value will be the absolute maximum and the minimum value will be the absolute minimum value of the function. So the third step is going to be identify the maximum or the minimum values, or minimum value. Identify the maximum or the minimum value. So this maximum or the minimum this maximum or the minimum value will be the this maximum or minimum value will be the absolute maxima absolute maximum or absolute minimum absolute minimum value of the given function f. Absolute minimum value of the function f, So this is the working rule for finding the absolute maximum and absolute minimum. So we'll understand this method by considering an example problem. Well, the example 39, it is find the absolute maximum and minimum values of a function f of x equal to 2x cube minus 15x square plus 36x plus 1 on the interval, that is closed interval 1 comma 5. So what does our working rule says? First we will have to find the critical points. I'll take f of x, which is equals to 2x cube minus 15x square plus 36x plus 1. So this is the given function, plus 1. This is the given function. We will have to go for differentiating this with respect to x. So we get f dash of x. So here f dash of x, which is equals to, so what do we get now? 6x square, then minus 30x, and then here we get plus 36. In all the three terms we can take 6 common. F dash of x, which is equals to, take 6 common, we get x square minus 5x and then plus 6. So now f dash of x, which is equals to 6, write it as it is, then x square minus 5x plus 6 can be written as x minus 2 into x minus 3. X minus 2 into x minus 3. X minus 2 into x minus 3. So now multiply these two, you get back the previous term. X into x, it is x square, and then minus 3x minus 2x will be minus 5x, minus 2 into minus 3 will be plus 6. So equate this with the 0 to get the critical points. Now f dash of x equal to 0. So overall what do we have now? 6 times x minus 2 into x minus 3 is equals to 0. So we get x minus 2 equal to 0 and then x minus 3 equal to 0, because if we take 6 to the RHS, it goes to the denominator. 0 by 6 is always 0. So now what are the critical points here? X equal to 2 and x equal to 3. From this you get x equal to 2. And from this you get x equal to plus 3. This is x equal to plus 3. So now we will have to evaluate. So we are done with the first step, finding the critical points. What is the step number 2? It is evaluate the given function at the critical points and at the end points. That means at x equal to 2, at x equal to 3, and at x equal to 1, and at x equal to 5. Overall we should get 4 values. So here now we shall evaluate. So now we shall evaluate the function f at x equal to 1, and then we'll write in the increasing order, at x equal to 1 and at x equal to 2, at x equal to 3, and at x equal to 5, and x equal to 5. So we will go for f of 1 f of 1 which is equals to, so replace x by 1 now, so you get 2 into 1 cube, 2 into 1 cube minus 15 into 1 square plus 36 plus 1 plus 36 plus 1. So now simplify this, how much we get? 1 cube it is 1, 2 into 1 it is 2, 2 minus 15 it is minus 13, minus 13 plus 36 will be 23, 23 plus 1 it is 24. So like this you will have to evaluate, it is 24, and then now I will go for f of 2. So replace x by 2 now, 2 into 2 cube, then minus 15 into 2 square, then plus 36 into plus 36 into 2 plus 1. So if you simplify this you get 29, and then I'll go for f of 3 now. This is equals to 2 into 3 cube minus 15 into 3 square plus 36 into 3 plus 1. So now simplify all the terms, you get 28. Then the last one, it is f of 5. See here, 1, 2, 3, 5, f of 5, which is equals to 2 into 5 cube, 2 into 5 cube. In this I am substituting minus 15, it is 5 square plus 36 into 5 plus 1, which is equals to plus 1. So simplify this, you get the answer as 56. So now out of all these 4 values, which is the greatest? That is going to be the absolute maximum or the global maximum. So the greatest is 56, and which is the least value among all the 4? So the least value, it is 24. So here 24 is the absolute minimum and 56 is the absolute maximum. Therefore absolute maximum, therefore absolute maximum value equal to 56, absolute maximum value equal to 56, occurring at the point x equal to 5. 56 occurring at x is equals to 5, occurring at x equal to 5. Now what is the second point? Absolute minimum value equal to, what is the lowest? It is, or the least value it is 24, occurring at x equal to 1. So this is how you need to find the absolute maximum and absolute minimum values of a given function.